Hello and welcome to today's video in which we will be continuing to practice optimization using derivatives. So in today's video we have another exercise which consists of a box which we know that has a square base. This is a box that has a square base and we want to minimize its volume knowing that it has 600 squared centimeters. 600 centimeters squared. We have our length, our width, and our height. But we know that our length and the width are the same as the problem says that we have a square base. So length and width are the same. Our variables, we'll call our length and our width x, and we'll call our height just height. So let's write our auxiliary equation. As we know that the total surface area is 600 centimeters squared. We have two square bases and then the rest. So this would be 2 times L times W, which is basically x squared, plus 4xh is equal to 600. We know that our optimization function is also L times W times h, which is basically x squared times h, and we want to maximize this. This is our volume. This is our volume function, our optimization function. So what we do here is we isolate for h. First of all, we can divide everything by 2 in order to obtain more easy numbers to manage. X squared plus 2xh is equal to 300. And now we just isolate h. We say that h is equal to 300 minus x squared, and then obviously divided by 2x. We substitute our h into this equation where we have that the volume only in terms of h is x squared times 300 minus x squared divided by 2x. We can cancel this x out and this squared out, and we know that our volume function is finally x times 300, 300. X minus x times x squared, which is x to the power of 3. And that is going to be our volume function that we can therefore derive. So now all we have to do is do the same that we did in our last video. Find the derivative of the volume function and then just equal it to 0 to find our local minimum. Let's just do the following. Instead of applying our formula of one function divided by another, we can say that our 2 here is a constant and just take it out, saying 1/2 times 300. Obviously, we get rid of the x, we only keep our constant, minus 3x squared. And then this is 1/2 times 300 minus 3x squared over 2. Now we just equal this to 0. We pass the 2 to the other side, so we get rid of it, and we have that 300 is equal to 3x squared. We can basically simplify this, saying that 100 is going to be equal to x squared by dividing both sides by 3, getting rid of our 3's. And now we just say that x is equal to square root of 100, which is equal to 10 centimeters. And our h, is just going to be 300 minus our x squared, which is 10, so 10 squared, divided by 2 times 10. And then our h is going to be 300 minus 100, 300 minus 100, which is 200, divided by 2 times 10, which is 20. And therefore, our h is also going to be 10 centimeters. So, to minimize the volume, we have that our length and width have to be 10 centimeters, and our height has to be also 10 centimeters in order to obtain 600 centimeters cubed of surface area. That is what we need to minimize the volume. Thank you for watching. I hope you have understood optimization using derivatives. And if not completely, check out my previous video and my next video, which will also be about optimization using derivatives. See you in the next video.